Let me introduce our first speaker, Chris. Chris from Microsoft. Chris is a technical specialist, security and compliance at Microsoft. He is a hands-on technical leader, and he is a creative thinker and a subject matter expert across Microsoft's security and compliance solution portfolio. And as you can see, his topic for tonight is identify, classify, and remediate threats with AI and automation.
So I'm excited to talk about this because it's a super exciting upcoming trend. So I want to talk a little bit about how security operations centers work. And generally, there's this notion of 3 tiers of analysts, and all SOCs should have a desire to drive as much automation as possible into their operational processes. Automation ensures that analysts spend less time on each incident, reducing the attacker's time to operation. Automation also ensures analysts aren't bogged down in manual administrative tasks so they can react quickly to new detections. And most importantly, analysts have more time to engage in proactive activities that both reduce organizational risk and increase morale by keeping everybody focused on the mission of cybersecurity. And this mission should always be oriented towards limiting the time and access attackers have to organizations' assets in order to effectively manage this business risk. So let's first see how AI and automation can help achieve this goal. But first, let's frame this conversation by discussing some of the challenges we see SOCs facing today. The recent trend, we all don't need to explain this, but the recent trend in the evolution of attacks has absolutely highlighted that many of these attacks cannot be detected in a deterministic way. And if they could be bypassed quite easily. Attackers are leveraging standard tools in their campaigns, and standard behavior is much harder to detect when considered malicious. And SecOps teams get far too many alerts. Many of them have a lot of trouble prioritizing what they should be looking at. And in truth, we need to focus on what matters the most impactful entities. Insider threats are also a much bigger risk, cybersecurity risk, than external ones, with 74% of cyber incidents happening from within organizations. As was the case with the SolarWinds attack, many of these signals went unnoticed as their activity was happening inside corporate networks, and many SecOps teams were too heavily focused on external threats. So when we think about investigating the scope of a breach, in general, investigating the scope of a breach is a very long, complex, and traditionally a manual process. Many security operations teams have telemetry data from a ton of different systems. These disparate systems, many rely on manually correlating these related activities from disparate data sources in order to try to make sense of what's actually happening. And this leads to a bunch of problems. So this endless barrage of all this security data that is increasingly growing makes it incredibly difficult for defenders to effectively correlate events at speeds needed to contain a threat. And in the end, many SecOps teams get stuck in this endless loop of chasing things that don't exist, or more importantly, things that don't matter. We say, don't spend your time sorting gravel. We've all heard that notion of don't sort gravel, schedule the big rocks first. And when we think about just trolling through tons of security data and sorting gravel, we lead to a bunch of challenges. The first is we miss real detections while chasing false positives. And 2, attackers continue to operate freely until they're evicted. So in order to address these challenges inside of our SOC at Microsoft, we decided to transition to our platform backed on the principles of machine learning, AI, and automation. And we did this so we could distill the billions and billions of events per month that we see into a few key 100 investigations. And in doing so, our SOC has enabled an over 90% true positive on alert feeds, which has allowed our team to focus on critical metrics that matter the most, such as mean time to acknowledge and mean time to remediate. In fact, our SOC actually sustained 100% growth in incidents handled over a 3-year period with a nearly flat staffing level. Now that's astounding. We don't know if we can expect that trend to continue, but it definitely validates that we're on the right track and we should really share our learnings. So how does SecOps go about realizing these astounding gains we've seen over the years? AI and automation, of course, that's the only way we can get a handle over this. The problem is many traditional platforms and security tools, they have these silos of data. And as discussed earlier, these silos of data make it incredibly difficult to make sense of the data. Many tools have mapping challenges. Many tools pivot on different attributes. Believe it or not, I've actually seen some SOCs during very critical incident response scenarios trying to correlate events based on timestamp. That is not at all a sustainable model. Don't sort gravel. And this recent wave of very sophisticated cyber attacks in nation states has hit home the importance of clearly understanding the relationship between these different domains. How an attack that might be facing an endpoint can be moved to laterally move to an identity, eventually compromising cloud resources and additional application resources. We need to understand the relationship between these domains in order to get a handle over these attacks. So as a result of these challenges over the last few years, we've been leveraging a ton of AI and automation within our platform to help close these visibility gaps. So we took all the high quality existing detections we had in our existing security products, and we introduced signal sharing. All of our products share signal with one another. And we extended this by unifying our entity definitions. So what this means is when I see a particular file hash that might be spotted in a mailbox, and that same file hash pops up on an endpoint or within a SharePoint, Teams, or ServiceNow instance, I can understand what's truly happening and that these entities are related. So once we unified these entities, we basically were able to dispatch a ton of machine learning and AI to provide semantics and meaning across these massive data sets. And this allows for clearly defined scope and context. So these very complex attacks that span many different endpoints, identities, mailboxes, or applications, we can make sense of it. We then layered on a ton of out-of-the-box automation capabilities to help coordinate response against all of these different domains in your environment. So how do these improvements really manifest themselves from a day-to-day security operations perspective? So this is a common scenario that many SecOps teams, I think we're all familiar with in cybersecurity, where somebody receives a suspicious message. Now, this is generally, in most cases, a task that can take a while to follow up. There's a triage. Let's review the email, review the headers. What do we know about this email? And then diving further into the investigation. Who else got this email? What are the relating emails based on sender IP and subject? Did anybody click the links in these emails? What about the user's devices who ran these potential malicious emails? Like, are they infected? What other anomalous behaviors are we seeing with these users? And then ultimately contain the threat. Delete those messages, clean up or isolate endpoints that might be infected, block any additional URLs. I've seen this process take hours and hours in many SecOps teams as a manual response effort. So we address this by introducing a ton of automation in our platform. So our holistic approach to security with these integrated tools backed on the principles of AI and automation can easily surface all of this data we need. We have automated investigations built into our Defender for Office and Defender for Endpoint suite that dynamically surfaces all these key entities involved in these complex attacks. As you can see, we can actually identify that this malicious file was also spotted on an endpoint, and what are all the related entities and processes on that endpoint in question. These two tools provide coordinated defense between email and endpoint that is absolutely amazing. Just look at the quantity of data we're able to surface for a security analyst perspective. No longer do I have to hunt across all these manual disparate systems, correlating these events manually. I can clearly see everything I need to see to make a determination about this threat, whether it's the ultimate latest threat details about this threat, whether it's mail authentication details or sender IP or sender domain details, whether it's all the related messages in this particular attack, whether it's a timeline of URL clicks in that particular message, whether it's all of the files, processes, services, drivers related to the endpoints in this attack, everything is surfaced for me to quickly make a determination about this threat. So this AI and automation is a huge help, and it's a great starting point. But let's see how we can augment additional forms of security intelligence to really make this even better. So we can extend all this traditional intelligence and AI with leveraging our cloud-native SIEM Azure Sentinel. And this allows you to import a ton of additional threat indicators, which I'll show you in our demo, that your organization might be using to enhance your security analyst's ability to better detect and respond to threats. So how do we keep these threat intelligence indicators updated? AI, of course, that's all we can do. Every day, our global security team, we sift through trillions, over 8 trillion security signals a day, and we leverage a massive amount of AI and machine learning to distill these into actionable intelligence that we can feed across our various products, platforms, and services, ultimately culminating in a ton of new detection algorithms, which are continuously validated and tuned within our platform. We combine this massive amount of intelligence with advanced machine learning algorithms to better understand user entity behavior. So UEBA is all the rage. We leverage UEBA to build standard profiles and behaviors that are unique to your organization. That's key, unique telemetry data based on your user insights. And as discussed earlier, malicious behavior from inside your organization represents a far greater threat than external ones. And organizations such as ourselves at Microsoft, we model our cybersecurity strategy as though attackers are already observing us. And organizations that take that stance, they can ensure that they have those mitigations in place because their models assume attacker intrusions. And this is really where UEBA comes in handy. So, UEBA in a nutshell, it's a capability within Azure Sentinel, and it really eliminates that drudgery of having to dig up different forms of data according to your users. We can basically eliminate the uncertainty and the efforts by providing high fidelity, actionable intelligence so your SecOps teams can focus on what matters most. Sentinel collects logs from tons of different data sources, all integrated with our security platform, and it analyzes them and builds these behavioral profiles of your organization's entities. And using a ton of variety of techniques and, again, machine learning capabilities, Sentinel can then identify anomalous activity and help you determine if an asset has been compromised. So not only that, but it can also figure out the relative sensitivity of assets, identify peer groups of assets, and even evaluate the potential impact of a given compromised asset. And the culmination of everything I've shown earlier around AI, machine learning, threat intel, and UEBA is in our fusion detections. So fusion technology is, again, based on machine learning, and Sentinel can automatically detect multi-stage attacks by identifying combinations of anomalous behaviors and suspicious activities that are observed across the kill chain. And on the basis of these discoveries, Sentinel generates incidents that would be otherwise very difficult to catch. And these incidents are comprised of 2 or more related alerts or activities. And by design, these incidents are low volume, high fidelity, and high severity. Exactly what we need in our SOC to achieve a greater than 90% true positive rate, so we can focus on what matters the most. So here's a listing of some of the sample fusion detections we have in Sentinel. You can see, sign-ins from anonymous IPs followed by anomalous Office 365 activity. And this list goes on and on. This is just a sample of some of the fusion detections backed around machine learning and AI that we have in Sentinel, and we're constantly updating them out of the box. So when you adopt this platform, these detection algorithms are turned on and enabled, ready to go. So how do we automate things even further? We've shown how we've distilled a massive amount of events using machine learning and AI into a clearly defined list of high fidelity, actionable incidents. Security playbooks extend that capability by automating the response to even those low volume, high fidelity incidents. So security playbooks in the Microsoft ecosystem, we design them on what's called Azure Logic Apps, and they have a ton of readily available connectors to automate a ton of different actions across a variety of applications and services. Now, when you're thinking about designing a playbook, we need to think about well-defined procedures based on a known issue. What are good candidates for playbooks and automation are generally repeatable actions in response to high-fidelity events, exactly like we described. So I'm going to dive into a demo and show you a ton of the stuff that we've shown over this session, combining a security automation demo that's going to combine threat hunting, anomaly detection, and threat intelligence in a single go. We make it super easy in the Microsoft security ecosystem because we provide, again, a unified data schema. Whether you're looking for logons on workstations or servers, whether you're looking for cloud data, whether you're looking for logons in Teams, SharePoint, ServiceNow, we collect and unify all that data. Whether you're looking for email events, any emails you want to find, you can search for them. We have all of the raw data available in these tables that you can hunt across. And security operations that are pivoting to leveraging advanced hunting, rather than waiting for these alerts to come in, although our out-of-the-box detections are great, using hunting from a day-to-day perspective to look for and spot trends and threats is a far better approach to many organizations. So this unified data schema full of identity data, email data, every endpoint data, you can use to immediately answer conclusions. Say you want to look for a certain file hash across the entire environment. With a few lines of KQL code, you can find it. Show me all emails matching a certain sender IP. Show me all devices that have launched a process a certain way. All of this data is at your fingertips. And once you kind of get familiar with using KQL, playing with our query language, understanding the table and data schema, it becomes really, really easy. We have an entire schema reference in here for hunting. So if I wanted to say by chance, what do we look for on endpoints that are using our security tools? We can see a listing of every single device event that we collect across our platform. So say I was wondering, hey, do we collect if somebody mounts a USB drive? Is that something I can look for in the environment? Indeed, we do. We actually have the ability to search for anybody who's mounted a USB drive or anybody who's created or added local user accounts. So this schema reference is an awesome guide as you're getting familiar with the advanced hunting framework. So we talked a little bit about sorting gravel. How do I hunt? So what you can do from a hunting perspective is there's this really cool method that we can use. And we teach this method in a lot of our security webinars, and it's awesome. I like to call it our gravel sorting method. And it's called series decompose anomalies. And this is actually a method that's baked into Azure Data Explorer, and it's part of the KQL language. And it allows you to take a massive set of data and extract anomalous points. It's exactly what we need to hunt through the gravel for the big rocks. So where can I use this series decompose anomalies in playing around with advanced hunting? I mean, once you understand how this works, it's really, I mean, it's such a creative avenue for hunting. So take, for example, take every single IP address that every device in my entire environment has ever visited in the past 30 days. So when you take a massive sample size like that, 5,000 machines, generally machines communicate with the same sets of addresses. They communicate with Microsoft and your VPN IPs and all these different things. I want you to say, take that massive sample size across all of our device network events, and I want you to pick out the most anomalous IP addresses and sort them by max score. So this series decompose anomaly will look for anomalies across that data set and then surface them in a query. So here is a list of all the IP addresses that it's found that are considered anomalous, ranked by score. So obviously looking at the highest anomalous IP address in my environment is a cool way to do this. And one demo that I always do, this is a live lab environment that our product group uses. They attack it regularly. They use malicious IP addresses, they use malicious code, malicious PowerShell. They do whatever they can to attack this environment. So more often than not, I'll take a look at some of these IPs that I've found on the top anomalous list, and I'll use some crowdsourced intelligence, like abuse IPDB is a cool example. So I basically have this hypothesis that maybe this IP address is bad. And lo and behold, if I cut over to abuse IPDB and I check if this IP address is indeed malicious, I can indeed pull this up. And indeed, this crowdsourced website has said this IP address that we found was actually reported 47 times. And what I like about this is there's an API behind it. So we can tie automation to this, and I'll show you exactly how we can do that. But what's cool is it's because it's crowdsourced, you actually get user input and feedback on all the reports. People say, indeed, this has been trying to brute force my honeypot, or this has been trying to remotely connect to this particular port. So definitely there's malicious activity coming from this IP address. So that's one way you can sort of distill anomalous events in your environment using series decompose anomalies. The other way is think about files. Think of every file that's ever been opened using Outlook, Chrome, and Edge, right? Those are common business productivity tools in my organization. People are downloading files all the time. I want you to take every file we've ever seen from a download operation. So this is, again, using our device file schema table, pull out all the anomalies and look for every file that was downloaded in Outlook, Chrome, and Edge with maybe an Excel document or exe file format. And indeed, there's all of the files that it has considered and ranked by anomaly. And I can pivot off that. I can dive into that a little further to drive a little bit more automation. Now, I don't want to have to run these queries on a regular basis. I don't want to have to hunt for these anomalies on my own. How about we tie this to automation? And we can absolutely do this by integrating this with a playbook using something like Azure Logic Apps. So Sentinel has a massive amount of threat indicators that we can ingest. One creative way to look at what's hitting your own environment is through honeypots. I mean, many people create honeypots in their own environment, in their own address ranges, to try to get some feedback of what are attackers doing, where are they coming from, and who are actively exploiting my environment. So standing one of these up in something like Azure and exposing it and isolating it, and just taking a look at the telemetry data we get. If you use something like IIS to collect these, you can actually pull the geo coordinates natively out of this. So you can actually very creatively, using some KQL queries, just show a map of all of the people trying to attack my environment in a regular basis. So what I'm showing you here is just all the failed login attempts. Now, obviously, these could be legitimate failed login attempts, so I don't want to consider blocking all of these. Maybe if I drive a playbook to look through all of these failed login attempts or all of these anomalous IP addresses on a daily basis, cross-reference them with some third-party threat intel, and if you get a hit, maybe add it as a confident, intelligent indicator, maybe block it across all of my hosts. So I've done just that using a logic app. Super, super easy. It's a GUI-based designer. And I basically said, look, every day I want you to just run a query looking for anomalous IPs. In this question, I do have another one that looks for anomalous IPs. This one is actually looking for all failed login attempts across my environment. So simple KQL query that says every day, just hunt for every known anomalous IP address that we've seen in the environment. And for every IP address you find, I want you to cross-reference it against Abuse IPDB's API. They have a free API that anybody can use. I can submit that IP and I can return a list of abuse confidence score and things like that. So my playbook then basically says, okay, if you get a hit on that IP address where the abuse confidence is greater than 50%, I want you to go ahead and add it as an indicator, as a proper threat indicator into my internal system. So if I see that IP address anywhere else inside my system, right, on a server, on a firewall, on a network indicator, I'm actually made aware of it a little bit more proactively. I also say post a message to Teams. Post a message to the Teams channel and let my SecOps team know that, hey, we've detected this, we've vetted it, we've automated this process, and we've blocked this IP address across the environment. So this runs on a daily basis in my environment. So if I look at this logic app in particular, the last run is, indeed, we grabbed all the failed login attempts. This happened yesterday morning. Indeed, we returned a bunch of IP addresses in the environment. For every IP we found, we hit up the Abuse IPDB API, and you can see in here, it is returning every time I call that API. It's saying, yeah, indeed, we have a 54% positive abuse score with this particular IP address. So that's past my 50% threshold. I want you to go ahead and, as a condition, I want you to inject that indicator so it's blocked across all of my endpoints. And so it's added as an indicator in our cloud native SIEM. So if this ever comes up anywhere in the future, I'm made aware of it. And obviously the IP addresses change. So adding expiration dates and times, I've hard coded in here, just block this IP and make it an indicator for the last month. That way, if that IP address changes, these indicators continually get updated. So what ends up happening in this particular case is basically every morning, I get a message in Teams. And this message in Teams just indicates that, hey, indeed, we've detected failed logon IIS activity from this IP. We've cross-referenced it with crowdsourced intel, indicating that it is a 100% certainty this is a bad IP. 774 people have reported it, and we've blocked it across all of your hosts inside the environment. So pretty cool. That's actually one way that you can do it. And we also update these indicators regularly as well. Like, as much as we're sourcing our own indicators, Microsoft injects indicators into Sentinel on their own. We actually have a new threat intelligence connector that you can simply turn on, and Sentinel will inject 50,000 threat intelligence indicators per day from Microsoft. It's pretty cool. So every hour, 2,000 of these similar indicators are injected into my environment that I can use from a hunting perspective. If we ever see these indicators across my environment, I can be made aware of them. So you can see in here, I can actually just say, show me all the indicators that have come from our emerging threat feed. And indeed, I can see, 200,000 indicators that are coming from Microsoft. Many of these are exactly what I described. Attacker is using this IP address to brute force. So just like I harvested my own threat intel using honeypots, we're also injecting this threat intelligence indicators into the environment dynamically. Our security webinars are an awesome resource. Definitely check out aka.ms/security webinars. There's a massive section on advanced hunting and KQL. All the skills I've picked up around KQL and advanced hunting, they come primarily from our public security webinars. Check out our security podcast, and we've got great interactive guides if you want to see similarly how we navigate incidents, and a great book around our zero trust strategy called the Cybersecurity Landscape book.